there. I'm glad you're back. I'm still in this fabulous hotel room where I'm staying on Long Island, so I can go and have a major, awesome nerd hangout with other IB teachers in the morning. I know. Someday you too could have a life like mine, if you're lucky. Okay, properties of muscle tissue. Here we're going to get into all of the different, obviously, properties of muscle tissue. And just as an FYI, this is going to lead you right up into annotating the structure of a skeletal muscle. Now, I do want to make sure that we are very clear that this is from chapter 4. So this is the objective from 4.2.2 on your syllabus, and it's going to ask you to outline these properties of muscle tissue, right? As in, tell me the life story of each type of muscle tissue, right? So we're going to start with contractility. So all muscles can do this. This is the ability of a muscle to be able to contract, right? You can generate a force. The force is always going to be stimulated by a nerve, which we're going to get into later. But right now, you just need to understand that the muscle can exert a force. And if the force is strong enough to lift the resistance, then you're going to end up getting this phenomenon called torque, right? Where there's enough force to cause a rotation. So if you took physics, you probably remember talking a little bit about torque. And that's exactly what this is, right? Is that the muscle is contracting, it's exerting a force on the bones, and it's causing that bone to rotate. Just like, for example, when you are doing a, let's see, you're doing an extension, right? And you're a leg extension. So you're tightening your hamstrings, and the hamstrings are pulling back, and it's causing the femur to rotate around the joint that is your hip, right? Your pelvic girdle. So that's what I'm talking about when I talk about torque, and you will definitely see that word come up quite a bit in your book and on the IB in general. Okay, so muscles are usually arranged in pairs so that when one is contracting, the other one is lengthening. And we talked about this when we looked at reciprocal inhibition back in the last unit when we were looking at workouts, right? And program modalities. We're looking at the fact that when your bicep, for example, is contracting, your tricep is relaxing. When your quads are working, your hamstrings are relaxing. When your glutes are engaged, your hip flexors are relaxing, right? So everything has like its little partner in crime. Okay, extensibility. This is the muscle's ability to be stretched, right, beyond its normal length. Not like way, way, way beyond its normal length, right? It's just able to stretch beyond just a relaxing stance, right? So if you think about like your hand, like this would be, your hand is relaxing right here, but you can push it up and you can extend those muscles, right? So that is the property of extensibility. Elasticity is the muscle's ability to return to original resting length after the stretch is removed, right? Elasticity as well as extensibility, these things are what we see in the warm-up and the cool-down, right? This is when we're lengthening our muscles and we're sort of bringing them back to a normal place in terms of their length-tension relationship with their friend over here that we talked about, where one is relaxing and one is contracting, right? So that is an important property. Okay, so elasticity, extensibility, those two things are going to be really, really, really reinforced when you're looking at like why it's important to incorporate flexibility into a workout program. Just throwing that out there. Definitely going to want to know those. Okay. So for warning, you're going to see questions written in a purple font color. So if you did not do this in class yesterday and you're in 7th period, you're going to do this now. If you are in 9th period and you've never even seen this before, congratulations, you get to do this now. So every time you see a question written in purple, you're going to write these questions down and you're going to answer them. I know. Okay, I'm even going to make you a little submit button. It's very exciting. All sorts of things to do. Okay, so muscle contraction types. concentric contraction, isometric, eccentric, isotonic, and isokinetic. So these are all of the different types of muscle contractions that you can do. It's very exciting. What you need to be able to determine is, when are these contractions happening? Why do I care about them? And what are they best used for, right? So like, would I be working on concentric or isometric or eccentric contractions for bodybuilding, for, flexibility? What am I doing? So all of those things are going to come up. More will be revealed. Get excited. Okay. So here we have our isometric contraction. Look, it's Pilates. So this occurs when the contraction force is equal to the resistive force, right? So isometric means length, right? So the metric part is sort of saying like, okay, the muscle's not going to change its length. If it's contracted, it's going to hold that contraction in that spot, right? So this is usually done when you're looking at somebody who's lifting, right? This is done if you're doing like a tempo exercise. So you do 1, 2 on the contraction, 2-second isometric hold, and then 4 on the way down, 4 counts on the way down, right? The isometric hold is actually really important. It stabilizes the body. It helps you to get practice stabilizing the body. That's the only way you're ever going to get to lift heavier without hurting yourself, right? So while an isometric hold isn't directly going to build you muscle, it certainly will indirectly, insofar as it's going to allow you to have better stability in that joint, and then you're going to be able to lift heavier and heavier, thus leading to hypertrophy. Exciting. So examples are adductors and abductors during a squat, right? So your adductors are the muscles that are going to pull in your legs. Abductors are going to pull them out, right? And they have to be very dynamically balanced during a squat so that your knees aren't going out or they're not caving in, right? So that's just one example of how working on an isometric contraction can help you in terms of stability. And Pilates is pretty famous for that. This purple question, I think it may be cut off, but don't worry. I've also posted this PowerPoint slide separately. Can isometric exercises help build muscle? So you're going to need to do some researching on Google and in your textbook in order to answer that question. Okay, isokinetic. This is really crazy stuff. This is when your muscle shortens at a constant speed during the full range of motion, right? So the contraction is happening at a constant speed, the way that it's contracting and relaxing. Now, this is completely wild and crazy because we may think like, oh, okay, I'm holding the same speed of my contraction if I go down for 4 and up for 4 over and over again because I can count, right? Isokinetic contractions, if you really, really want to know that you are holding that contraction and that the same speed is going over and over and over again with each movement, you're going to have to use some really expensive equipment. This is going to monitor the amount of force that you're applying and adjust the load so that whether you go faster or slower or whatever the case may be, the force that your muscle is applying remains the same. So that's a little wild and crazy. So what you are going to look at in this question is the type of motion that's an isokinetic contraction. This is rare in sports and exercise. We don't really see it. So what equipment is required and why? Like, why would I do this kind of exercise? That's the question that you're going to answer. So like, what equipment do I need to do it? And who would it be indicated for, right? Because they're definitely going to ask you that on the IB. And then I'm going to ask it on the test. So you should just know it for sure. Look it up. Okay. Isotonic contraction is a force is produced, muscle tension is developed, then it relaxes. It's like the whole cycle is this isotonic contraction, right? There are 2 phases of an isotonic contraction. You have concentric and eccentric phases. A concentric contraction, right, is when the muscle is shortening and it's bringing 2 bones together, right? And we usually think about this as flexing, right? When the angle between the 2 bones is going to get smaller. it causes a body segment to move, and the rotational effect of the force from the muscle is greater than the resistance. So basically, the force of your bicep is greater than the resistance of the dumbbell that you're holding, and therefore your arm, even with the added load of the dumbbell, your forearm can still travel up towards your bicep. Awesome. Now, what's cool about this is that, again, we see the word torque popping up, right? And that's kind of awesome because if you know about torque, you can really use it to your advantage, particularly if you're looking to build lean mass and bulk up. So I usually don't provide resources from places like bodybuilding.com, right? But this is some really awesome science that you should look at in terms of weight placement and exercises. And in fact, you have to look at it because you have to answer the question, how does placement of a weight affect the amount of weight used to perform a task, right? So I want you to think like, how much would you lift if you were doing bicep curls versus a reverse fly? Is the position of the weight making you able to like cheat on your move? So it sort of looks like you're lifting more, but because of the way you're holding a weight, you're actually not lifting more, right? And you'll see all of that in the link that I provided. So you're going to answer that question as well. I know this is getting very okay. So more on muscle contractions. So this is just like the same thing I said before. And I don't know why I put it again, but you know what? Doesn't hurt to read it twice. Go for it. Eccentric. So if the muscle is contracting, but the rotational effect of the muscle is less than that of the resistance, then you've got eccentric. What do I mean by that? So basically, an eccentric motion is when you are allowing something to fall due to gravity, right? So if you're doing a curl, right, on the way down, that's your eccentric motion. So the load is going with the force of gravity. They're going in the same direction, but the control that you have over those weights as you lower them, so that they're not just dropping, right? That is working. It's called working the negative in bro science, right? It's the eccentric motion of the muscle. So what you are going to look at for this, right, is you are going to look at different exercises and finding their concentric motion and their eccentric motion. And I'm also going to ask you to look at why you do have days of your training program where you're working the negative, right? What's the point of doing that? So you'll be answering that question as well. Oh, look, it's over. Okay, so I'm going to make sure that you have access to some place to submit this on Schoology so that you can answer those questions that I just asked you. And yeah, carry on, friends.